Okay, in this section 1-7, we're talking about transformations of functions. So what we'll be looking at is how changing the equation affects the graph, how it changes the graph. And we start off by looking at some of the parent functions. And remember, the parent function is the simplest equation of a certain type of function. And so we've got 6 of them to look at here. So first one, linear, y equals x is the simplest linear function. So that's the parent function. So just to kind of remind you of how the shape of the graph for each one of these functions are, linear function, line, absolute value, v-shaped graph, square root function looks like this. Let me see, squared, x squared creates a parabola, x to the third cubic forms this shape, and then 1 over x, okay, rational function. All right, so that's just kind of a quick reminder of what those functions look like. Now, let's talk about how changing the graph affects or changing the equation affects the way the graph looks. Okay, so first of all, you've got your vertical translations. So if you add something to the end of the function, then that's going to shift the graph up by that many units. If you subtract something off of the end of it, it's going to shift it down that amount of units. And so we can illustrate that pretty quickly by graphing it as well. You can kind of see what we're talking about here. So I'm going to pull up Desmos calculator. And so I'm going to put the parent function for x squared in there. So y equals x squared. So we've got the quadratic parent function in there. All right, so let's compare that to y equals x squared plus 3. All right, it shifts the graph up by 3. And if I change that to minus 3, it'll shift the graph down by 3. All right, so everybody is aware of how that works. Okay? Another way that the graph can be shifted is through a horizontal translation. All right, so for a horizontal translation, then the graph or the equation, you would have to add or subtract something directly to the variable within a set of parentheses. So like, for example, here, if you subtract something off from the x value, that's going to move it that many units to the right. And then if you add, that's going to add it, move it that many units to the left. All right? And just remember that that may be opposite of what you typically think, because remember, to the right is the positive direction on the graph. Well, when you add, then it's going to actually move the graph to the left. And to the left is the negative direction on the x-axis, but when you subtract it directly from that variable, then that's going to shift the graph over to the right. So to illustrate that, we'll come back here. We can use parent function again. And so this time I'm going to open a set of parentheses and go x. Let's go plus 3. We're going to close it off and square it. And notice when I add 3 directly to the x, it shifts it over to the left by 3 units. And you know what's going to happen if I were to change this to minus 3? It's going to shift it over to the right by 3 units. All right? So that's horizontal shifting. Right? Let's take a look at vertical dilations. And so now, if I multiply that function by a value, if that value is greater than 1, then that's going to cause what we call a vertical stretch. Okay, vertical stretch. If that value is between 0 and 1, that is going to cause what we call a vertical shrink. All right? And so if the number that you've multiplied directly to the function, depending on whether it's greater than 1 or between 0 and 1, will determine whether or not that a vertical stretch has occurred on the graph or a vertical shrink has occurred on the graph. Let's see what it looks like on the graph itself. And so, for example, if I were to take this x squared, this quadratic function, and say multiply it by 5. Let's say 5x squared. All right? So again, since the value that I multiplied by was greater than 1, it's caused a vertical stretch to occur on the graph. So it's almost like taking the graph and stretching it out vertically. Like for example, if I were to draw this parabola on a piece of stretchable plastic, and then I took that plastic and stretched it out vertically, then that's what the drawing of the graph would appear to be after it was stretched out. Okay? Likewise, if I were to take that 5 and I were to change it to 0.2, let's say, and then that's caused a vertical shrink. So it's compressed the graph vertically. All right? Now, the next type of movement that we're going to be looking at is a horizontal shrink or stretch. Okay, so this time, okay, if you're multiplying a value directly to the variable, if that value is greater than 1, that's going to cause what is known as a horizontal shrink, a horizontal shrink. And so it's basically compressing the graph horizontally is what would be happening. And then if the value is between 0 and 1, it causes what is known as a horizontal stretch. So it would be like stretching out the graph horizontally. Let's take a look graphically how that would appear to us. So in a set of parentheses, if I've got, say, multiply the graph times 5. So I got 5x, let's close off the parentheses, and now square it. Okay? So again, since my value here is greater than 1, it's caused a horizontal shrink. So basically the graph has been compressed horizontally. It's been compressed horizontally is what's happened here. All right? And if I come through and I change this now to like a 0.2, all right, then it has been stretched horizontally. Stretched horizontally is what's happened. Okay? And so the vertical and horizontal stretch and shrink, it can sometimes appear to be the same way on the graph, but the way you can tell which one has occurred is by looking at the equation, and you can tell which one has occurred there. All right? Really one more type of movement we need to take a look at, and that's the reflections. And so if we take the graph and we change this sign of it here, then that's going to cause it to reflect through the x-axis. And so an illustration of that would be if I put negative x squared up here, then that would flip the graph through the x-axis. And likewise, if I were to take the graph and make the variable itself inside the set of parentheses negative, then that would cause the graph to reflect through the y-axis. And here, I'm going to actually change my graph a little bit, because if I were to do this with the quadratic function, then it would actually just flip over the y-axis and look the same. So what I'm going to do here is I'm going to do the same thing that they did here in the example on your notes, and I'm going to use the square root function. So I'm going to take this off, and we're going to change it to the square root parent function. And so what I'm going to do here now is I'm going to come here and go square root, okay, of negative x. And then so notice what happened is when we do that, it has reflected through the y-axis. Reflected through the y-axis. So again, making the entire function negative, okay, we'll flip it through the x-axis, and just making the value of the variable negative, we'll flip it through the y-axis. All right, so at this point, now that we've kind of gone through how these changes will affect the graph, then what we need to do is we need to kind of take a look at some different equations, different functions, and our task is to describe the transformations from the parent function to the function listed below. All right, and so the first function that we have is cubic. So we want to know is take a look at the equation, and based on the equation, describe how the graph has changed from the parent function. Now, a good order to do this in would be the same order that has been presented to you in your notes. I would go through and I would list the vertical translations first, list the horizontal translations second, okay, list any vertical or horizontal shrinks or stretches next, okay? And then I would go with the reflections last, all right? So let's take a look and see how it would work. Okay, so when we go through and look at this graph, first thing I want to see is if there is any vertical translations. So there's nothing added or subtracted from the end, so there's no vertical translation movement there. There's no up and down movement. Okay, so let's go to the left or the right movement. So here I've got a +1 added directly to the x. So my first movement I'm going to record is just going to move the graph 1 to the left. All right, 1 to the left. That's the first movement that I would record. Next, I want to get into my vertical and horizontal dilations. And remember, for that to occur, all right, then number has to be multiplied directly either to the entire function or to the value of the x itself. In this case, we have a -1/2 multiplied, okay, by the entire function. And so if that's the case, remember, if it's multiplied here by the entire function, you can look back at your notes, and remember that's going to be a vertical dilation. Now, let's look at the value that is being multiplied. It's 1/2. 1/2 is between 0 and 1, so that's going to cause a vertical shrink. So that's my next movement. We have a vertical shrink. Okay. And sometimes you'd be asked to actually list out the factor of vertical shrink by 1/2. Okay. I'm just asking you to write it that it's a vertical shrink is all we're doing in this lesson. All right, now there's one more movement that's happening here, and that's because of this negative. Well, remember, this negative is going to cause a reflection. And if you go back to your notes, that negative will cause a reflection in the x-axis. So that's my last movement. Okay, reflected. And with the x-axis. All right, so there you go. So that kind of accurately describes all of the movements that are taking place here. Okay, let's go to the next function that we have. It's also cubic, and there are two movements to describe. The first movement, based on this, I would say is 2 up. The next movement, based on this, 1 to the right. Okay, 1 to the right. Okay. The third one here, first movement I would describe here is 10 down. Okay, the next movement I would describe here, since this is +3 being added to it, that's going to be 3 to the left. Okay, 3 left. And again, I've got a negative here, so that's going to be reflected with the x-axis. Okay, reflected with the x-axis. All right, so that kind of concludes this lesson. And like I say, remember the objective is to be able to describe how the graph has been translated based on the way they've changed up the equation. And your quiz will be waiting for you in your Canvas course.